So in this lesson, we're gonna go over go over geometry, and just some prerequisites. Just a little bit of the basics, so then you get a feel of what geometry entails. So what does geometry entail? That is cool. So geometry is, let's write it again, geometry is the study of points, lines, angles, surfaces, and solids. So we are going to dive into all of these. So let's start with the basic is what is a point? So point. So this is a point, but what does it mean? So a point, this is a location in space, and it's represented by a dot. So this is a dot. Oops. If I get my pen to work, this is a dot. So you can have a lot of dots, and what you'll start noticing when we go through is that when you connect, when you connect all these dots, you start getting different shapes, right? So I'm sure you're familiar with your triangles, squares, and circles. Circles are dots, but they're a bunch of dots, doing this number right here. And then I'm sure you're familiar with, a box, right? If I can draw one correctly. Or even a can, right? Not the best looking can, or even a, like a little basketball, right? I can draw correctly. So all these are a bunch of dots, and when you string a bunch of dots together, you get a line. So we'll go over what a line is. So a line is a collection of points that extend forever, right? So this is key, because I'm getting a little bit ahead of myself, because when we start drawing these shapes, right, and we have to stop the line, right? So the line keeps going here, right? But we have to stop this line, right, because we want to create like a little shape, right? Okay, so we can label this A, B, C. Okay, and so C to B, right, so this would be segment CB, but if we continue, we continue this, you know, I've seen people do it. You know, this is line CB, or it could be BC, right? You know, but it's better to try to put the first letter where you're starting the point, starting, and where you're ending. Okay. So we put 2 points to name the line, right? In this case, it would be, in this case, CB or CF. It is perfectly normal. And then now I got a little bit ahead of myself. The segment is the stopping point. Stopping point. So in this line, A, B, C, D, E, F, G, H, I. You have segment I, AI, right? Segment AI. Then you can also have segment AB. Now, what's the line? The line, if we so choose to do it, the line will be line AI, and then we denote that by this. Now, we've talked about lines, which extends both ways. We've talked about the segment. But what if we want to talk about, you know, a one-directional way, another directional way, right? These are called rays, right? So you're kind of seeing how this all flows together. So a ray, this is a collection of points that begin at one point, and this would be the end point, and extend forever in one direction. So remember, when we're labeling these, so let's look at this. This is A. Okay, we'll call this B. So we start with this. This is the end point and the direction B. Right? So you can also have this. Let's call this B. And you know, you would label it B A, but then the direction would be here because you're denoting it. Now if I connect two rays, let me clear this out. If I connect two rays, I get an angle, right? And so you've probably heard of, you know, the right angle. This is 90 degrees, not 98 degrees. If you're, well, you probably won't be old enough to get this humor. There used to be a band called 98 Degrees. So now keep in mind, you know, this can extend here, and this line can keep it simple, but we're not concerned with the entire line. We're concerned with only a portion, and then this is the angle. So we're concerned with the angle going, you know, on forever. Right? But you could even draw angles with just segments. So getting a little bit ahead of myself, you have a triangle, right? So the angles here, here, here. And then what is this? Well, in order to do the angle, you know, we know this is 360 degrees. Why? Because we have an angle here, an angle here, an angle here, an angle here. And when we go around 90, 90, 90, 90, we get 360 degrees. So when you measure the angles, when measuring angles, it doesn't matter. It doesn't matter how far the end point extends, right? Because the angle will still be the same regardless, right? You're just making it more difficult to yourself the farther out you go. But this angle is the same as this angle, same as this. So we want to try to use that, because when we extend the lines, we're extending it from the angle. Okay. So next we got planes. Okay. When we talk about a plane, we're talking about a flat surface. I.e., think of paper, or this surface I'm writing on, right? So this surface I'm writing on is just flat, right? So when we say planes, we're not talking about, if I can draw one, we're not talking about the little airplanes with little engines. We're talking about, like a regular sheet of paper, right? And then what you need to know is this is to help you visualize, but it's a flat 2D surface that goes on forever. But most of us cannot visualize or imagine the concept of forever, right? But so what we're trying to show you is this is trying to make something that's abstract more concrete. And so it's a 2D surface, and it can be up and up and down to the right, or at an angle that's still like that. And so when we take planes of different going in different areas on a 3D surface, that's how you get your little 3D objects, because you have an XY coordinate. And then so let me try drawing this. So you have this plane, but notice how I'm shifting the plane. And then you kind of have it like this, and then like this, then like this, then like this, then like this, like this. So these are all planes, but it's kind of hard to imagine these, how you can look at it from different areas. And when you start getting to more deep mathematics, this will all make sense, right? When you start doing, your derivatives, your integrals, and especially when you get into calculus 3, we'll just call it calc 3 and diff EQs. God, I can't write today. Diff EQs. You'll start seeing that we go beyond the X, Y, and start introducing the Z plane, which makes everything a bit more hairy. Right? And so these concepts that don't make sense now will make sense when you get into higher mathematics. So if it doesn't make sense now, that's okay. But these are the basic foundations for your higher mathematics. Otherwise, you just can't grasp it. So moving on, we got parallel lines. I can't even spell it. Parallel lines. In parallel, if you think of parallel parking, what do you do when you parallel park? So you have a parking spot, right? So your car, you can draw a little goofy car. So your car, and so this is the engine, kind of an oversized engine. So your car, when you're doing parallel parking, you're here, but what you're trying to do is you're trying to go into between the two lines, right? And you're not trying to touch these two lines, you're trying to be in between. And that's essentially what we're trying to say with parallel lines, that there are lines that do not touch each other, right? They go in the same direction. So this is parallel, this is parallel. Oh, I'm drawing a segment. Gotta have the arrows. Right, they're not trying to touch. Now, if they do try to touch, we call them intersecting lines. So intersecting lines, so think of it, well, you know, when you're driving and then you get into like a, like an intersection in the car, like this road intersects with this, like this road intersects with this road, right? And then you keep going. That's essentially what we're talking about. We're intersecting lines. They're going to meet at a point, right? And so we call it point A or something. Now, where they meet, this is called a vertex. So, I threw a lot of terms at you today, but these are the basic terminologies to help you understand, and they build on top of each other, right? So we started with something basic, such as a point. Then we went into what a line is. A line. Then I said, well, what if we don't want to look at the entire line? Let's just look at this segment, right? Oops. Let's not do that. Right, so this is the segment. And then I said, well, what if we only want to look at one portion of the line, right? So these are the rays. And then I was like, well, what happens if we connect them? Right? Then we get to the rays to get the endpoints together, right? And then this is the angle. We always denote an angle with a little curve. And just getting a bit of my head of myself, we will always denote a right angle with the little box. Any other angle will always have a little, little semicircle type deal. And then I was like, okay, so we did the angle, but what if, what is this surface on? The point, the line, the segment, the rays. And we talk about something called a plane. And now I made it a bit more complicated after that and said, well, within the plane, what can happen within the plane? Well, you could have parallel lines. I said, but then these lines can also intersect. Right, intersecting. Intersecting. Then I also said, well, we got to identify this, which is the vertex. So I threw a lot of terms at you, but hopefully this all makes sense because this is all building on one another, right? So hopefully that helps you understand the basics of geometry. So, let me know what you would like to learn more about or what concepts you're struggling with, and I'll be happy to show you. All right, take care.